Right, so we want to show if this is true or false. For positive integers m and n, m times n factorial is the same as m factorial times n factorial, and m plus n factorial is the same as m factorial plus n factorial. So let's go ahead and so proof, we're going to let m be equal to 2 and n be equal to 3, right? So we're going to see if this works for this case, right? So we have mn factorial is the same thing as 2 times 3 factorial, which is 6 factorial, which is, it was 6 times 5 times 4 times 3 times 2 times 1, which that's, so let's see, so 24, 30 times 24, right? Because 6 times 5 is 30, 4 times 3 is 12, times 2 is 24. And then this will be 30 times 20 plus 4, which is the same thing as, so this is 600 plus 120, which is 720. Okay, so let's go ahead and see 2 factorial times 3 factorial, right? Well, that's significantly smaller than 720. I can see that. So this is 2 times 1, right? Times 3 times 2 times 1, which is 2 times 6, which is 12. So I can see that this is not true, right? Mn does not equal, so Mn factorial does not equal m factorial times n factorial for every m and n, for every positive integer m and n, right? So that's not true for every m and n. Now let's go ahead and let m be 2 and n be 3 for the next one. So let's look at m plus n factorial, and we let m be 2 and n be 3, which is 5 factorial, which is, so 5 factorial was that, well, let's go ahead and do it. 5 times 4 times 3 times 2 times 1, which is 20 times 6, which is 120. Okay, so now m factorial plus n factorial is equal to 2 factorial plus 3 factorial, which is 2 times 1 plus 3 times 2 times 1, which is the same thing as 2 plus 6, which is 8. So I can definitely see m plus n factorial does not equal m factorial plus n factorial for every m and n contained in the positive integers. So we can see that both of these, like this statement in altogether, is false, right? So this is false. And that was like a little proof showcasing that these are not true by a counterexample.